Hello, I'm Taryn Campbell, lead programmer for the Tardis repair company. Me and my sisters, Devin and Tegan, are a homeschooled robotics team from Tomball, Texas. Unfortunately, I'm out of town at the moment, so I've put together this video to show you how we programmed and engineered a robot named Gizmo. This is Gizmo, our faithful robot servant. He has been built to be easily modified and has 4 sensors to accomplish his missions, 3 color sensors and 1 touch sensor, as well as 2 motors to drive his wheels and an additional 2 motors to power several mission-specific attachments. The first thing we did as a team was decide how many points we should try to get, which would impact the amount of missions we would do. We saw that there were more points on the board than you could complete in the time available. After the team reviewed the board and the missions, we felt confident that we could get about 100 points. We then grouped what missions were close together in order to complete as many as possible in a single run. We identified 4 runs that grouped together the 6 missions. We timed the missions individually and accounted for changing out attachments. Then we ran them all together to ensure we were within the 2.5-minute time allotment. To design our robot, we first needed to understand the requirements of each mission. After we reviewed the missions, our engineer and programmer discussed what features could be used on the board to position the robot, such as black lines for line following and object location for the touch sensors. Tegan, our lead engineer, then built those components onto the robot, and I, the programmer, started to work on the code to position the robot for each mission. One thing we've learned is that using 2 color sensors for line following greatly improves speed and accuracy. We also mounted color sensors on the front and back of the robot so it can move forward and backwards more efficiently. Our team has done lots of robotics competitions such as World Robotics Olympiad, FLL, and Best Robotics, and we've adopted the motto, fail fast. If something doesn't work, we move on and try something else before we invest too much work into it. For example, we attempted the feeding mission but found that it was taking too much time to get the food and to place it correctly. We abandoned that mission and instead focused on the bee and pig missions. To help simplify our code, we use MyBlocks, which can be reused throughout our program for common functions like line following and to determine if a motor has stalled. One block can represent a lot of complex blocks. If you look at our code, you will see I use these extensively. I also ensure that there are lots of comments so anyone can fix the program if it's not working correctly. To make sure the robot is working properly, we run the program in sections and use sound blocks to announce where the program has progressed. This helps us troubleshoot any problems in the code. Since our robot has to operate autonomously, we need to automate as much as we can. You can see in this video that our robot uses a number of sensors to advance across the board and complete its missions. There is a lot of programming that is required to make Gizmo complete several missions in a row without getting stuck. Some of the features that we are especially proud of include using multiple sensors to provide more fault tolerance for our robot and is able to complete multiple missions at once. As it progresses, you can hear the use of sound blocks to indicate how the program is progressing. We also use an extensive line following and our touch sensor to determine where the robot is located on the board. I have also programmed stall blocks in case motors get stuck performing an action. It can release itself and continue on its mission.